Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about another theorem related to moment generating function. So here what we have is many random variables which are independent. So we have all independent random variables labeled as x1, x2 up to xn. And for each random variable here, we have the moment generating function for each of them. And over here, we have another random variable denoted as y, where y is the combination of x1 plus x2 until xn. Then for every value of t such that this guy here is finite, then the MGF of y, we can obtain the MGF of y by using this formula given here. So again, I'm going to start this discussion by simply summarizing what is all about. So basically, here what we have is we have many random variables. We have x1, we have x2, we have x3, we have up to xn. And each of these random variable here, they are independent. And they have their own MGF. So this is the first MGF for x1 and MGF for random variable x2, denoted as such according to the definition. That is the symbol used. Okay, the third MGF and the last one. Okay, so our problem is we have a new random variable which is y. Y is the combination of x1, x2, x3 dot xn, and we would like to find, well, if you see this here, x1 related to this, x2 related to this, related to the previous information that we have, and so we would like to find what is the MGF for y. So itu yang kita nak cari. Tercakap BM pula. Okay, so I'm sorry. So yeah, so that is what we're looking to find, and the formula can be obtained. You can use the formula given in this purple box. Okay, right. Now I'm just going to prove that the statement given here is true. So in order to prove it, it is very simple. We will start off with the starting point of finding the MGF for y, and we all know what is the starting point. So it is just the expectation of e, t, and y, and you are just going to replace y with the representation given. So this is our y, so just replace that, x1 plus x2 plus x3 dot xn, and we're going to expand it, so it becomes tx1 plus tx2 plus tx3 dot txn, and using the law of exponent, that becomes multiplying all the terms. Okay, so that is what is going on. We are doing multiplication process right there, and because they are independent, okay, the result will become like this, due to the fact that x1, x2, x3, all of them are independent. So to those that have no idea what's going on right here, recall that when you learned covariance. Okay, when you learned about covariance, there's this formula here involving the expected value of x and y. So and if x and y are independent, therefore exy becomes ex dot ey. So this is something that you have seen in the previous video related to the formula of covariance. So this simple idea here is brought forward in this case. Okay, so these are all random variables and they are independent. How do you know they are independent? Well, it is given in the assumption here. It says that this theorem here is in a setting where, set in the situation where all the variables here are independent. Okay, and because of that, we can separate them into these terms. Okay, so similar to the simple idea that you have seen in the video related to covariance. Now, the next part is identifying what that is. So clearly, this is the MGF for x1, right? So this is the MGF for x1, T, MGF for x2, T, MGF for x3, T dot 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 MGF for random variable xn, T. And because the process here is all multiplying all the terms, there is a simple notation that we use. So we use this notation here to denote the multiplication process of MGF xi t, where I from 1 to n. So the formula, the symbol used here is to denote the process of multiplying all the terms given here. It is something like using sigma to denote the process of having all the terms add up. So here we have all the multiplication, and we're just saying that we can use the symbol here to consider multiplying all the terms right here. Okay, so basically that's the idea. So that's the proving part, and we are done with it. And let's look at the practical example given here related to the theorem that I've just explained. And again, what I'm about to show you is that when I try to solve this problem, I will not be concerned too much about memorizing this formula, because because you will see that when this problem is solved, the process that is involved in solving this problem is very natural, in a sense that you don't really need the formula in that purple box, okay, in order to solve this problem. So let me just show you how. Well, we have y1, y2, yn. Whoops. What's going on? Hang on. Okay, let's try this again. So right, what we have here is we have y1, y2, yn, and they are independent. So this is the keyword, they are independent, and the MGF for each of them is similar. Okay, they have the similar MGF. y1 is this MGF, y2 is also this MGF, yn is also this given MGF. Now we have a new random variable called w, and w is the combination of y1 plus y2 and so on until yn, and the question is asking you to find the MGF of w. And again, like I've said just now, I don't think we need the formula given here. You don't have to memorize it, because the process that you are about to do or you're about to see is very natural. Okay, so let me just explain to you. In order to find the MGF for w, so here we have, this is what we are looking to find, MGF of w. the starting point is of course to find the expected value for E, T, W. So this is our random variable. And the next natural step that you can take is of course to substitute W with the given expression here, y1 plus y2 dot 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 yn. Okay, so that is the given expression for random variable W. Next, we're just going to expand this, take out the bracket, so it becomes ty1 ty2 dot 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 tyn. Okay, using the law of exponent, this becomes ty1 multiply with y2 dot dot dot. Okay, so this is what happens. Next, recognize that they are independent, each of them, because it says here y1, y2, yn are all independent. Therefore, the process can be written as y1, okay, you can separate that, y2 dot dot dot, and that's it. Okay, and what is, so this is just the MGF for random variable y1, MGF for random variable y2, MGF for random variable yn, and the MGF is given by this guy, so write it down. Okay, that is for the first one. The second one is also similar, so write it down, and the last one is also similar. Okay, next what we can do is we have the same term multiplied n times, therefore it becomes PET plus 1 minus P to the power of n, and this is the answer for moment generating function of W. Okay, that's all for now. Thank you very much for watching.